We have been working on disjoint sets, and we have seen how disjoint sets are useful in search algorithms, and how disjoint set can be represented in the form of a graphical way in the tree-like structure. Yeah, that's arrows pointed upwards instead of downwards. That's the difference between this one and the tree. And here the nodes are pointing towards the root instead of root pointing towards the leaf. So from the leaf it goes up to the root. The root is the one which is a leader of the group or leader of the set. Any element can be leader of the set, but one of them is identified as leader of the set, so that it will be easier to identify whether two elements belong to the same set or different sets. Okay, then we found that how do you identify to which group it belongs to? So the only option is to reach the root. So how did we reach the root? So if we started from 15, then from 15 we went to 11, from 11 we went to 3, from 3 we went to 5, from 5 we went to, that's one which is minus 1, which states that when you reach minus 1, that means no more possibility to move further. So it says that the last one before reaching minus 1, wherever you were, that was the root. Okay, that's the logic. So we are trying to find the root. So any node I is given, then P of I will be parent of I. So P of I is, P will be this array. So P of 8 is 10, P of 6 is 2, P of 3 is 5, and so on. And P of I is minus 1, which means 5 is the root. It doesn't have any parent. Okay, what we have to do is, if you are asked to find the root of 15, so you start moving upwards. So 15's parent you find. So find parent of 15, and we reach 11. Then find parent of 11, we reach 3. Then find parent of 3, where we reach 5. Then find parent of 5, we get minus 1. That means whose parent you were trying to find got a minus 1. You need to stop there. And for whose parent you were looking for gets you a minus 1. That itself is the root. So that's the logic. So how can we do? So this was I, parent of I was 11. The next step, I becomes 11, which gives 3. Next step, 3 becomes I. So which means I should be replaced by parent of I each step. How long? As long as parent of I is greater than 0. As long as parent of I is greater than or equal to 0, we need to do this. So first time I was 15, so we started with 15, parent of I for 15, parent of I, it said 11. Then go to 11, parent of 11 is 3. Then go to 3, it says parent of 3 is 5. Then go to 5, it says parent of I is minus 1. So it breaks this when I is equal to 5. When I is equal to 5, this is broken, then just return the value of I. Now, if I just run this, so P of I is 15, P of I is 11, greater than that, yes. So 11 is transferred into I. Then P of 11 is 3, which is again greater than equal to 0. So 3 gets transferred into this. Then parent of 3 is 5, which is again greater than, therefore this gets transferred into this. Then parent of 5, we get -1, therefore the loop breaks. So this line no more run when I is equal to 5 and return I, so it will return a 5. So that's the logic of find. So this is going to return the leader of the set or root of the set. So that's the simple logic which used to find leader of any set. So anything given. So if you are asked who is leader of 2, then repeat this. 2's parent is 16, 16's parent is 17, 17's parent is 7, and 7's parent is 5, and there is no parent of 5. Therefore, we end this loop at I equal to 5. So for this also, when you ask for root of 5, 2, it will tell that it is 5. Yeah, that's the simple logic for identifying root of any disjoint set. So many issues to discuss in our coming sessions. So keep watching. Thank you.